Hello everyone, welcome to Josh Max channel. In this video, we are going to see for CBSE Maths Grade 12 Standard Chapter 5 Continuity and Differentiability in Exercise 5.1 20-second sum. Already in the last videos, I have uploaded till 21 sum solution. So please do check it. Now let's start with the 20-second sum. Okay. So what is the given question? Discuss the continuity of the cosine, cosecant, secant and cotangent functions. So here 4 trigonometric functions has been given. They're asking us to discuss the continuity. So before moving on to the solution part, let me tell you one thing. Remember that always all trigonometric functions, that is sine, cosine, tangent, cosecant, secant and cot, all 6 trigonometric functions are always continuous in its domain. Okay, and it's not necessary to prove every trigonometric function is a continuous. Okay, it's enough to say that is sine and cosine are continuous. Now with the help of the algebraic properties of the continuous function, what are the algebraic properties of continuous functions? Sum of two continuous functions are continuous. Okay, and then a difference of two continuous functions are continuous, product of two continuous functions are continuous, and quotient of two continuous functions are continuous. So once we prove that sine and cosine are continuous, then from that we can say the other four trigonometric functions are continuous. Okay, so cosecant is inverse of sine, right? So we can say that sine is a continuous, so the inverse, that is if it is in the p by q form or inverse form, are continuous as per the algebraic properties of continuity. So we can say cosecant is continuous in its domain. Same way secant, we can say the secant is what? Inverse of the cos. So we can say cos function is continuous. So obviously secant is continuous. Cotangent. Cotangent is what? Inverse of cos, inverse of tan, that is cos by sine. So we know that two continuous functions in the quotient form, if it is in the p by q, still it's a continuous. So we can say the other four are continuous with the help of cos and sine. So now I'm going to prove here as a sine function is continuous and cosine is continuous. With that, I'm going to say the remaining other function cosecant, secant, cot are continuous. So let's start now. So here we are going to discuss the continuity of sine first. So for that, I'm going to consider let f of x equal to sine x. Okay, so throughout the real line, we are going to check the continuity. Throughout the real line, we have infinite real numbers. We have no, so we are going to have some common variable to check the continuity. So which variable we can have? Any variable is fine. So we are going to, like as usual, let me take it as a c. Let c be the any real value. Any real value. Okay, real number or real value. Now to check the continuity, what are the things are required? So we need f of c. Okay, then left hand limit is required. Left hand limit of the c and right hand limit is required. So when all these values are coincide, we can say that the function is continuous, right? So let me find f of c first. Okay, so in place of x, I'm going to replace c. Then what happens here? F of c equal to sine c. Okay, now same result we have to get for the left hand limit as well as for the right hand limit. Now left hand limit x is approaching to the c and sine x. F of x is sin x. Directly I'm replacing it as a sin x. Okay, now left side closed values of the function of, for the value c are approximately c, but those values are smaller than c. Anyway, smaller than c, right? Since it's a trigonometric functions, we should have a substitution, that is x equal to c minus h here. Okay, because what is that h here? Interval differencing. Suppose if it is 3, no, the closed values of 3 are 2.99, so it's approximately 3, but it is small little difference will be there, no? So that difference we have to take it like a h, so c minus h. Okay, if x equal to c minus h, what happens here? If x is approaching to the c, then your limit will change it like limit h is approaching to 0, then x is what? You have to replace a c minus h. I hope you understand. I'll repeat. So basically here, only for the trigonometric functions, generally what we do is the left side closed values are approximately c, but those values are smaller than c. So for that, for balancing that, no, so we are going to take the interval differencing, that is x has a c minus h you have to replace. Okay, then why here h is approaching to 0 means if x is approaching to c, that means what? X equal to c, if you replace in this condition, c equal to c minus h. Say, taking c to the other side, so which is 0. So h takes the 0, no? So if x is approaching to c, okay, if x is approaching to c, h is approaches to 0. Then replace x as a c minus h. Okay, now we have a formula. Sine of x minus y formula. Using that formula, we are going to expand this. So before applying the limit, so limit h is approaching to 0. Sine of x minus y formula, as per that formula, let's substitute here. So sine x, that is sine c, cos h minus cos c sin h. Now let's apply the limit in this. So if you apply the limit, so in place of h we have to apply the limit. So here it is in the cos h, here we have a variable h, and sin h, here we have a variable h. Only in these places we have to apply the limit, and sin c cos c are the like a constant. So now let me apply the limit. So cos sin c into cos 0 minus cos c into sin 0. Okay, now sin c, cos 0 value what? Cos 0 degree, which is 1. So cos 0 value 1 minus cos c, sin 0 value, it's a 0. So if 0 is getting multiplied with the cos c, the entire term becomes 0. Then 1 into sin c, it's going to be sin c. You will have only the first term, sin c. So left hand limit gives the result sin c. Now same way we have to prove for the right hand limit. Okay. Now right hand limit, limit x is approaching to the right side, okay, from right side, that is sin x to the sin x for the sin x function. Okay, now here we have a c. Okay, from the right side the limit is getting approached to this particular real value. Right side close values are approximately c, but those values are anyway greater than c. Okay, so for that interval differencing, what I'm going to do is I'm going to make a substitution, x as a c plus h. Okay, so x as a c plus h I'm going to substitute in the function. Okay, now limit, I'll come to this part now. Now in place of x, what is the replacement? C plus h. So here x is approaching to c, right? If x is approaching to c, that means what? Generally we will make a substitution, x equal to c, no? Just substitute in this, c equal to c plus h. Then what is the h value that you will get? H equal to 0. That means h is approaching to 0. If x is approaching to the c, where h approaches to 0. Now substituting here. Okay, now we know that sine of x plus y expansion. So using the trigonometric formula, we have a formula that for the sine of x plus y. So using that, we are going to expand the sine of c plus h. Now limit h is approaching to 0. The expansion of sine of x plus y is sin x cos y plus cos x sin y. So using that, let me rewrite here. So sin c cos h plus cos c sin h. Now applying the limit. So sin c cos 0 plus cos c sin 0. We know that cos 0 value is what? 1. So cos 0 value is 1, and cos c here sin 0 value is 0. So if 0 is getting multiplied with anything, it's going to be 0. So second term fully 0. With the 1, if you multiply anything, same thing only will get. So sin c. Sin c plus 0 is what? Sin c. So now we can notice that here right hand limit is sin c. Now here you can notice f of c value, left hand limit, right hand limit, everything is coincide. Now from this we can say the sine function is continuous. So here f of c value, left hand limit and right hand limit coincides. So we can say that f of x equal to sin x is continuous. Similarly, we are going to prove for the cos function. After proving the cos function, the remaining other functions, no, we can say cosecant, secant, cotangent are continuous in its domain using the algebraic properties of the continuity. Okay, now here I already taken f of x as sin x, no. Now I am going to make a substitution. Let g of x equal to cos x, and I am going to prove that cos function is continuous. Then proving the other trigonometric ratios. Now let g of x equal to cos x. Okay, so now for all real values, basically we are going to check the continuity for the cos function. So let's see be the any real value. Okay, so to check the continuity for the cos, we have taken the c is a some real value. To check the continuity, what are the things is required? F of c is required, left hand limit, right hand limit is required. Okay, all this stuff is required. Now all these three should be same, then only we can say cos x is continuous function. Now let me find out f of c first. Sorry, here g of x, no, so g of c. So let's see be the any real value, any real value. Now g of c, so in place of x just replace x as a c, then this gives you cos c. Now left hand limit we have to find out, and while finding the sine function itself, I told only for the trigonometric functions we are going to take it like a interval differencing. Okay, for algebraic functions normally it's not required. So now for the left hand limit, left hand side closed values are approximately c, but those values are smaller than c, no, so you have to make a substitution x equal to c minus h for balancing. Okay, so take it for the left hand side as a c minus h, and for the right side as a x equal to c plus h. Like point the decimals, no, the approximate values we can compensate like this. Okay, so now limit x is approaching to the c for the function. What is the function? Cos x. As I told you, from the left hand side it's approaching, no, so replace x as a c minus h. If you replace x as a c minus h, if x is approaching to c, what is the meaning of this? X takes the value c, so replace here x as a c, then c minus c equal to minus h, then c minus c, which is 0, equal to minus h, then we can say h equal to 0, h is approaches to 0. If x is approaches towards the c, then h approaches towards the 0. So replace here h is approaches to 0. Now we have a formula in the trigonometry, that is expansion of cos of x minus y. Using that formula we are going to expand this. So now limit h is approaching to 0. The expansion of cos of c minus h using cos of x minus y formula. So cos a cos b, cos a cos b minus, sorry, plus sin a, that is sin c sin b. Okay, so this is the expansion of the cos of c minus h using that a minus b, that formula. Okay, now let me apply the h value here. Now h is approaching to 0, right? Wherever you see h, no, just replace it as a 0. Now cos c, and here cos h, no, that is cos 0, and sin c and sin h value sin 0. Now cos 0 value what? 1. So here cos c cos 0 value 1 plus sin c sin 0 value 0. Since sin 0 value is 0, if 0 is getting multiplied with anything, the entire term gets 0. Okay, now you will have only the first term, that is cos c. So left hand limit gives you cos c value. Now similarly we are going to prove for the right hand limit. So I already told you, for the right hand limit we are going to take x as a c plus h. So limit x is approaching to the c from the right side. Now cos x. Okay, so for the interval differencing, what we have to do? Cos in place of x as a c plus h. Similarly here what will happen if x is approaches to c, h approaches to 0. Now using that cos of x plus y formula, just expand this and then apply the limit. So now limit h is approaching to 0, here cos c cos h minus sin c sin h. So now if you apply the limit, cos c cos 0 minus sin c sin 0. So as usual, cos 0 value 1 minus sin c sin 0 value 0. So 0 is getting multiplied with sin c, the entire term becomes 0, and here 1 into cos c is cos c. So what we have, the right hand limit is cos c only, right? So now we can say that g of c value, left hand limit, right hand limit, everything is same. So what we can say from this, if everything same, we can say that cos function is continuous, that is g of x equal to cos x is continuous. Now this is more than enough to prove the other trigonometric functions are continuous. Okay, so what is now let's go gets back to the a question. So here discuss the continuity of cosine. So we have done here. So in the second part, let g of x equal cos x, we have discussed the continuity of the cosine. Now we can move on to the next part, that is cosecant. Discuss the continuity for the cosecant. Cosecant is what? The inverse of sine function. So here first let's complete for the cosecant, then we can move on to the other functions. So cosecant is what? So we know that cosecant x, cosecant x is 1 by sin x. And we know very well, if anything in the form of p by q, the denominator should not equal to 0. If it is 0, what happens? It's undefined. So make sure you write sin x not equal to 0. Where sin x becomes 0? Multiples of pi. So that is, we can say cosecant is continuous. Here x should not take multiples of n pi, where n is belongs to some integer. Okay, now we know that here, above we proved that sine is a continuous function, right? Sin x is continuous, and as per the algebraic properties of the continuity, if anything in the inverse form or quotient form also continuous. Okay, so from this we can say 1 by sin x is also continuous. Then we can say cosecant x is continuous. Okay, now what is the second next one after cosecant? It's given secant. So secant, how we can write? Secant is a cos function reciprocal, right? So we know that secant x is, we can write as a 1 by cos x. Okay, now remember denominator we have cos x, right? Cos x never equal to 0. Then what is that x here? When cos becomes 0, we know that very well, x should not equal to 2n plus 1 into pi by 2. So where as usual n is belongs to some integer. Okay, so if only a cos value, when it becomes 0, it 2n plus 1 pi by 2. So here cos becomes 0. So since cos in the denominator, it should not become 0. Okay, so other than this, any other values it can take. So only for the domain we need to say. Okay, so we know that cos x is continuous, right? Cos x is continuous. Above we have a proof of it. So cos x is continuous. So then obviously 1 by cos x is also continuous. So as per the algebraic properties of the continuity, then we can say secant x is continuous from this. Okay, got it? Now last one in this, cotangent function. So they're asking us to prove cotangent is continuous. Cotangent is what? So we know that is cot x. We can write as a cos x by sin x. And remember, denominator sin x is never equal to 0. And when what values x should not take, that is x not equal to n pi, where n belongs to some integer. Okay, so that means what? Here we know that sin and cos both are continuous. Sin x and cos x are are continuous. Then obviously cos x by sin x. So two continuous functions, if it is in a quotient form also continuous, are continuous. Then obviously cot x also continuous in its domain. Okay, that's all the proof of this, and thank you for watching, and please do subscribe. Thank you.